Hello everybody, my name's Paul, and for the next hour I'm going to be your guide through the neutron module focusing on moderation. But before we get started, I wanted to share something with you which is from my first experience when I started my nuclear training on day one. I was sat in a class with around 16 other students and our professor walked in carrying a football and pulling out of his pocket a small bouncy ball. And he asked us to imagine that our football was our nucleus, the nucleus of the atom, and that our bouncy ball was our nearest orbiting electron. And actually relative size isn't far off, so we can all imagine that. He then asked us a question as to how far do we have to throw our bouncy ball, the electron, to get it into that nearest orbit. And to help us put it into context, he said, imagine placing our nucleus, the football, at the bottom of Nelson's column in Trafalgar Square. But now, how far do we have to throw our electron? Well, we all sat and had to think about it in our class, and some of us thought it would be on the edge of Trafalgar Square, just a few hundred yards away. Others thought it would be a bit further than that, and we thought it would be middle of the Thames. And only a few others thought it would be further than that. As it turns out, we have to throw our electron due north till it hits the M25, around about 18 miles away. And that really cemented in my mind an image of our atom and of it being mainly free space. And that got me asking the question, well, how does that work? Because the physical world around us and everything we know in it is made up of mainly free space. So that really set me off with a hunger to learn more about nuclear physics, and in particular subatomic particles. So I hope that's given you an appreciation of how I started my training, and I hope that's given you a hunger to learn more, as it did me all those years ago.